All right, so we have what's called a radical expression, and a radicand. So this symbol right here means a radical. We have other kinds of radicals. We can have cube roots, we can have fifth roots. So we have other kinds of radicals, but it's that symbol of that we see here is what we call the radical. So an expression written with a radical is going to be called a radical expression. So that could be square root of 3, or it could be 2 minus the square root of 3. There's radical expressions in both of those. You could have an equation in there as well. So the part that is under that radical, that expression that is under there is called the radicand. So for our examples, the radicand, I have a hard time saying that, is 3, or in this case, it's x minus 3. So it's whatever that square that's under that square root, that is my radicand. So if I asked you to take this one, identify the radicand, well, that radicand is just going to be the x squared minus 16. So it's just whatever under our square root. Okay, so like I said, we're touching a few things here. So mostly when we're trying to look at things, we're going to be dealing with that radicand, then we're going to do the square root. So if I'm wanting to graph the square root of x plus 3, well, if x is going to be negative 3, let me do some adjusting here. Give ourselves a little bit of space to write in. So if x is negative 3, well then g, that should be a g, not an f, I'm sorry. G of negative 3 would just be square root of negative 3 plus 3. So order of operations would say I'd have to do that, simplify that radicand first, which is just going to be 0. So what we have here is the square root of 0 is just 0. So I have a point at negative 3, 0. So right there. G of negative 2 is just going to be the square root of negative 2 plus 3, which is going to be the square root of 1. Well, the square root of 1 is just 1. Remember, just doing the positive root. So at negative 2, we're up here at 1. Well, if we do the square root of negative 1, well, that is just the square root of negative 1 plus 3, which is the square root of 2. And the square root of 2 is approximately 1.414. So we're not going to be able to put it in exactly, but we can give you an approximation of where that point should be. So at negative 1, we're at roughly here. So notice a little curve going on here. G of 0, well, that's going to be 0 plus 3. So we're going to look at the square root of 3. Okay, second, square root of 3, I don't have memorized. I don't use it as much. A square root of 3 is going to be approximately 1.732. So we're going to get a lot of decimals when we're trying to graph these. And that's roughly maybe about here. All right, G of 1. Well, that's the square root of 1 plus 3, which is going to give me the square root of 4. Oh, yay, something is easy, 2. Then the square root of 2, or sorry, G is 2, is the square root of 2 plus 3. So we're doing the square root of 5. And this, there we go. Square root of 5 is going to be 2.236 approximately. Oops, I forgot to put my 2 here. So that's maybe about here. So the general shape we're getting is this. So remember that really what square roots are is that they're an inverse of your, I'm trying to think what to say, inverse of quadratics. So actually, if I did negative, so I did my negative roots, we would get them all down here. So we'd have that's the same, this is the same. You notice that looks like a polynomial on its side or a parabola on its side. Just something to point out. Okay, so try on your own. So I try to pick some points that would be easier for this one. So just make a quick graph of the square root of x minus 1, and you're going to use that x is negative 3, 0, 1, 2, or 5. Okay. So you may have noticed to these points I can't actually graph. So if I'm in the real numbers, which is what we graph in, this is a real number plane. It's all the way on here. We don't have eyes or anything. It's a real number plane. If we did negative x is negative 3, then that's going to give me the square root of negative 4, and that is undefined. So simply, we just don't graph this point. Same thing here. This one's undefined. We simply don't graph that point. So we can't just put any number into x, only certain ones are going to work. If x is 1, then we get the square root of 0, which is 0. So we have a point at 1, 0. So pretty much we should be expecting to see that we're going to start on the x-axis somewhere. If x is 2, then we get square root of 1. So that's just 1. So this is 2, 1. If we have x is 5, then we have the square root of 5 minus 1 for the square root of 4, which is just going to be 2. So we have a point at 5, 2. And we're seeing that shape again.